Okay, so this is not on the final. The title of it is partial fraction decomposition. This will complete all of the different methodologies for, or methods for integration that we learn through Calc BC. After this, we just do more advanced integration, but at this point, you guys should have like basic integration, use substitution, integration by parts, which is voodoo, and then partial fraction decomposition. And pretty much after that, we just use one of these methods and then build upon it further. So under partial fraction decomposition, what I wanted to show you guys for the first example is without any, this is just algebra, without any calculus tied to it. I just want to show you, for example, let's say you guys had a fraction that was 1 over x squared minus 5x plus 6, how we would break this apart into two different fractions. Okay, so what we're going to check now is so just walking you guys through, if I saw this inside an integral, I would recognize that, well, I can't undo this simply by doing u substitution or integration by parts, or sometimes what people try to do is say that this is just ln of x squared minus 5x plus 6. And even just, don't write that part out. And then even just think that it's just chain rule. So they undo it by multiplying by the reciprocal of the derivative of the inside function, which is 2x minus 5. In the chat, if you know, in the chat, do you guys know why this is incorrect? So don't write that part out. Do you guys know why that's incorrect? Okay, I have a couple of people saying that. That is correct. The denominator is not linear. Very good. Okay, so I'll tell you guys right now, like into the next chapter, I see this mistake occur a lot. So what you guys are trying to do when we just did this reverse here, this reverse process here, is assume that this was some chain rule that you would use to get to this answer. The problem is, would you guys use chain rule to find the derivative of this? So if I asked you guys to find the derivative of this, would it be chain rule that you're using to find the derivative of that? You have two functions, and what sign is in between those two? What rule would you guys use to find the derivative of this? What rule would you guys use? Okay, good. So a lot of you guys are recognizing that it's not chain rule that you would use to find the derivative of this. This is the product of two different functions. So the product rule, if you apply it, is not going to result in this as the derivative. So that is that's the mistake that some people make. So what we're going to explore today is how is it that we can possibly simplify this expression so that it's really the sum or difference of two different fractions. So we're going to first start off with factoring. So if I can have you guys type into the chat, what is x squared minus 5x plus 6? What are the two factors for that? You factor that trinomial. And as you do so, I'm going to say that you know it's partial fraction decomposition. If you end up with something that's factorable on the bottom, that's usually a tip, or it's already been factored for you. And I have two answers. I have x minus 6 and x plus 1. And I also have x minus 2 and x minus 3. So just make sure you verify it, make sure it makes sense to you that it's x minus 3 times x minus 2, because a negative times a negative is positive for the 3 and the 2, and then negative 3x minus 2x is negative 5x, right? So that's going to be that one is a common mistake that I see throughout. So what we're saying right now is it's equivalent. What we're trying to find is if I were to decompose this into the sum or difference of two different fractions, what would the numerator be on top of each one of these factors? So if I were to decompose it, and this is basically going backwards from finding an LCD and combining the two fractions. So what I do is I create a variable a, and I say that's going to be the numerator for x minus 3, b is going to be the numerator for x minus 2. And then from there, what we do is we rewrite, we go through the process of what if I were asked to find, to put these two fractions together. Okay, what I would then do is say that, okay, well, the LCD for these two fractions happens to be x minus 3, x minus 2. So if you think back to Algebra 2 trig, what would you guys have to multiply this fraction by to get the LCD? The left fraction needs to be multiplied by x minus 2, very good. You would have to, it's missing an x minus 2 on the bottom. So you'd have to multiply both the top and the bottom by x minus 2, right? So a times x minus 2. Okay, so I'm just going to look at the numerator at this point, a times x minus 2. What would you guys multiply the second fraction by? Okay, perfect, x minus 3. So plus b times x minus 3. And in theory, if this ends up being the numerator, and actually let's just go ahead and put it all over the common denominator so you guys have that for your notes. Most likely you're going to skip having to put it over the denominator, but I wanted you to see that this should be equivalent to 1 over x squared minus 5x plus 6, that these two expressions should be equal to each other. Since this is always going to be equal to this, I usually skip having to write over the denominator and I just write this as the equation here. Okay, so at this point, there's two ways of doing it, of doing this problem. I'll show you the, let's say one is easier than the other. You guys pick. Okay, so for this example, what I'll do is I'll distribute the A and then group things so that the x's are together and then the constants are together. So go ahead and do that. So 1 equals a times x minus 2a plus b times x minus 3b. If I group my x terms together, I have ax plus bx, and then I have negative 2a and negative 3b. Okay, after that, you guys will notice that these two terms have an x in it. So if I factor out my x, but this time what I'm going to do is put the x at the end. And then let's just leave negative 2a minus 3b. Okay, so then when I look at my expression, the left-hand side, you don't have an x term here. Okay, it's just the constant. So technically, if you have no x term, what coefficient is in front of x? What coefficient is in front of x if there's nothing there? What coefficient is in front of x? Is it 1 or is it 0? So if I have no money in my pocket, do I have $1 or do I have 0? I have 0, right? So technically there's 0 here. So if I view this coefficient as the same coefficient as the left-hand side, that would be 0, right? So I know for a fact that a plus b must be equal to 0. I have another expression over on the left that was 1. That represented my constant. Over on this side, negative 2a minus 3b also happens to represent my constant. So negative 2a minus 3b is equal to 1. Okay, so what do you guys think you do after that? Algebra. What do you guys do after that? How do you solve for a and b? Okay, so some of you guys said elimination, some of you guys said substitution, either one. So let's say you guys set a equal to negative b to use substitution, then we would have negative 2 times negative b minus 3b equals 1. Okay, so 2b minus 3b, you guys would end up with, for a moment, I saw something else, sorry. So then you guys have negative 1b is equal to 1, b is equal to negative 1. How would you then figure out what a is equal to? Once you guys figure out what b is equal to, what do you guys do to figure out a? plug back into either one of the equations, either the top one or the bottom one. So A is then therefore equal to +1. Okay, so all of that work, by the way, this is the harder way to do the problem, but all of that work to say that initially, if I were to have the fraction 1 over x squared minus 5x plus 6, that I can rewrite this as the, and I'm going to scroll back up and zoom in. You would then plug it back into this expression right here that you see, and I'll circle here. So you're going to take that and plug A and B back in. So we would say A is +1 over x minus 3. And then B is -1 over x minus 2. So that's pretty much the process. And let me just talk to you guys about why it would be useful to do this. So if you were to add the calculus of it, that's all just algebra. If you were to add the calculus of it, and I just told you guys we wouldn't be able to integrate the left-hand side because of that quadratic problem at the bottom, or expression at the bottom that should be linear, would we be able to integrate that, the right-hand side? What do you guys think? What would we be able to integrate the right-hand side now? Okay, so that's all it is take the algebra, tie the algebra together. Usually you have something quadratic or factorable at the bottom, break it apart, and then we're able to integrate. Okay, so let's do two problems. One, we're going to, and then these ones I'll show you guys the easier way to do it. So example, and I don't know if you're still on that page, so I'll zoom in a little bit. So if you're still recording your answers. Okay, so for example number 2, we're gonna add the integral to it. Okay, so let's say that they asked you guys to integrate 4x plus 5 over x squared plus x minus 2 dx. The first thing, because I don't want you guys to forget all of your other methodologies up to this point, I see something quadratic at the bottom, linear on top. Okay, so then the first thing I should think about before I move on to partial fraction decomposition is what other method would you guys consider first before saying that it doesn't work? What other method might you consider for this one? If you have quadratic at the bottom, okay, so someone said simplifying first, that is true. You guys would see if you can factor and then a factor cancels out with the linear one on top. Okay, very good. That is one other way. What other things might you want to consider if you have something quadratic at the bottom and linear on top? What other method? Very good. Actually, use substitution is what you guys want to consider, because if the derivative of the bottom ends up being some form of the expression on top, then that top might be able to cancel out. So use substitution is going to be something you consider. However, sometimes when you do that, it still doesn't result in something that you would be able to find the antiderivative of without having to do partial fraction anyway. So let's go ahead and move on. Okay, so again, we do the algebra of decomposing this fraction first. As we do so, I'm going to just show you guys how I would do this problem rather than systems of equations. But I don't know when you guys go to college if they're going to refer back to systems of equations as a methodology for doing that. Really, systems of equations are if you have two unknown, how do you solve it? So what are the factors that would go on the bottom for this one? So you guys should be able to do this as... Okay, very good. So you have x plus 2 and x minus 1. X plus 2 and x minus 1. Okay, so then what we do is we always just assign a single variable to one of the linear factors and then do plus b over the other linear factor. So a over x plus 2, b over x minus 1. Very good. So then we know that to get to our answers, we're going to pretend that we're going to do LCD on the right? And what we would have to do to get the LCD is multiply the missing linear factor to each one of the rational expressions. So a times x minus 1 plus b times x plus 2. Okay, so multiply the corresponding rational function. So this one's missing the x minus 1, times it by x minus 1. This one's missing the x plus 2, times it by x plus 2. And keeping in mind, doing that process is finding the LCD. So if they already have the same denominator, I don't have to write the denominator. I'm just going to write what I need the numerator to be, which is 4x plus 5. Okay, so at this point, again, for the previous problem, what I did was I distributed the A, distributed the B, regrouped the x's to be together. And so then you can set it equal to 4 on the left-hand side if you guys wanted to, and then regroup and put the constants together and set it equal to 5, resulting in systems of equations that you can solve further. An easier method would be to look at what you could let x be equal to eliminate each one of these terms. So if I'm trying to solve for a, I can let x be equal to a one particular value that would make this 0. What value would that be? If you guys let x be equal to what value would make that 0? Exactly, right? If I plugged a 1 into that, that would be 1 minus 1, so then it would eliminate my a. I would just want to make sure that when I let x equal to 1, I'm going to let x equal 1 for all of my entire equation on both the left and the right. So I'm going to say let x equal 1. When I do that, 1 goes into the left-hand side and I get 4 plus 5, which is 9. Again, the a gets eliminated, and then 1 plus 2 is 3. So then I'm left with 3b. So then b is equal to 3. Okay, so now you move on to finding the other variable. So if you guys look at the other variable, you'll see that you have b times x plus 2. What is it that you would plug in for x for this expression to eliminate the b? Okay, and yes, just to generalize things, you would set that factor equal to 0, solve for it, and get x equals -2. -2 would eliminate that expression. So we plug -2 into all of my equations. So let x be equal to -2. Doing so, you guys are going to get -3 on this side. -8 plus 5 is -3. On the right-hand side, you guys have -2 plugged into this expression here gives you guys a -3. And a would therefore be equal to +1. So we're going to go back to our integral. And we are going to say integral of 4x plus 5 x squared plus x minus 2 dx is really the same thing as 1 over x plus 2. I just ask that, you know, this process is not very difficult, but that you guys remember to plug it into the right fraction as you go, and then plus 3 for over x minus 1. So again, just make sure you guys plug it in correctly, and then remember that you're not done with the problem. You're integrating at this point term by term, and each one of your terms is a rational expression. So the antiderivative of this now we can do because it's linear at the bottom. So that's going to be ln of x plus 2. Technically, always double check. That's also where the problems get a little bit more complicated, is if the term down on the bottom, if the derivative is a constant other than 1, you guys want to make sure you undo that by multiplying by the reciprocal of that. So technically the derivative of 1 is, or x plus 2 is 1. I'm timesing by the reciprocal of 1, which is just 1. And then 3 I can consider to be a constant that I pull out of the integral. And when I look at this, I'm looking at it as like I'm integrating that term and I'm integrating that term separately. And then once again, ln of x minus 1. I do want to point out on the AP test that they tend to like to condense log functions in the multiple choice as one solution. So if I were to condense this, where might I put 3? Where else does 3 belong before I condense it? As a power, as an exponent. Very good. So if you guys move it up as a power up on top here, then your expression, once you condense it, is the absolute value of x plus 2 times x minus 1, and then that exponent only applies to the x minus 1. Yes, thank you, Sophie. And then plus c at the end of all of this, because this is a general antiderivative, an indefinite integral, so plus c. Okay, so I'm going to have you guys attempt to find a and b on your own for this next or last example. How are you guys doing so far, by the way? I sometimes move through this one too quickly. You guys doing okay on the decomposing the fractions? And it's, again, just to break it apart so we can find the antiderivative. Usually I would say there's at least one multiple choice on the AP test that has partial fraction. And it's really easy to spot because you're just going to see the initial one either factored for you or something factorable. And then when you look at the answers, there's ln in it. So you know, okay, well, this is probably partial fraction. Okay, so let's try this one, method of choice. Go ahead and pick whether it's a system. Does anyone actually prefer the systems of equations method over what I just did above? Actually, some people in some years do prefer systems of equations. It's like a problem within a problem, to me. I got this matcha green tea from Amazon and it's delicious, you guys. Okay, so integrates 5x minus 3 over x squared minus 2x minus 3. And then go ahead and do the problem on your own. I forgot to put the integral there. And feel free to glance up if you guys need help with it. If you guys can just double check that that your resulting coefficients go over the same factor. But if you guys began the problem and you had your factors in a different order than mine, so b being over x minus 3 and a being over x plus 1, that's fine too. Your resulting answer should still be the same integrand. So yes, b can be assigned to a different factor. However, the answer for that value should be the same for so if you guys can double check that you have 3 over the x minus 3 and the 2 over the x plus 1. The steps in between might be slightly different because of that. And once again, it is, and when you guys are doing non-calc, it's not essential that you combine these logs, but it is possible on a multiple choice that the logs were combined. So in which case you would move the 3 up, you would move the 2 up, and then combine it as a product. The other things I wanted to discuss with you guys, more of like, instead of doing all of that A and B values, is just practicing really quickly with integrating something linear that that might not be as simple as that. And also keep in mind, when you guys have a subtraction sign with one of the numerators being negative, if you have a subtraction sign, when you do combine the logs, if there's a subtraction sign between your logs, how do you guys condense logs if there's a subtraction sign in between? Okay, the division with the left-hand expression being on top and then the right-hand expression being on the bottom. So just keep that in mind. So now what I'm going to have you guys do is kind of do a lightning round of this with if you had to integrate, for example, and it does show up. So I want to make sure that we, let's say you guys did do a partial fraction decomposition problem, or this could just be a problem in itself. What would your answer be for this one? Okay, so if, can I have you guys go ahead and work out? What do you think your answer for this one might be? And think about what your answer would, think if you took the derivative, is your answer the same as the integrand? Okay, give it another moment because I know some people are still working. You can, as a tip, you guys can always pull the constant on top out too, not have to think about that. Okay, so good. I see some answers coming through correct. Some of them are off by a constant, and that's why I wanted to talk to you guys about this problem. So you do have something linear at the bottom, right? So if you have something linear at the bottom, that means that you can integrate using ln. It's essentially u substitution in your head. So if you have a linear factor at the bottom, to integrate that, you would do ln of absolute value of 2x plus 1. Now let's think about checking our work, and we have a 2 I know out front here somewhere. Okay, if I were to check my work, ignoring the 2 and just ignoring this 2 and just looking at this, if I were to take the derivative of this, I would take 1 over 2x plus 1, but by the chain rule, I would be multiplying by 2. So if in a derivative I multiply by 2, what should it be that I'm multiplying by when I'm finding the antiderivative? Okay, good. If I'm multiplying by 2 in a chain rule for a derivative, if I'm considering an antiderivative, I need to undo that. So I should be multiplying by a 1/2. Oops, by a 1/2. And so I see some of you guys had your answer as ln of the absolute value of 2x plus 1, and then plus the constant. Does that make sense to you guys how we got that? And I feel like partial fraction decomposition is fine until that part, which is really calculus. The algebra is okay, and then we get to this part right here, and sometimes I see a mistake on that. Does anyone need, do you guys want to see another example of that? To try another one? Okay. So actually, let's see if, let's see what happens if you guys had like, well, let's say you guys solved for A and B, and you happen to have a 1/4 as the value of the constant that you had on top, 1/4. Okay, so you solved for, you're doing partial fraction decomposition, and A happens to be a 4th, so I've just put a 4th there. And this is what I see sometimes students do. And then 3x plus 2 at the bottom. Okay, go ahead and integrate that. There was a question, is there a partial fraction decomposition where there's a coefficient in front of x squared? And yes, those are going to be the ones that result in finding an antiderivative that has, if you think about if the coefficient at the very beginning is a number other than 1, it's going to result in factors that have a positive value other than 1 in front of x. So kind of where I'm pointing here, the 3. So if we factor and we end up with values that are like other than 1, that's these types of integrals that I'm doing with you guys right here. Okay, good, Brandon. That's right. Go ahead and type into the chat. What do you guys think the answer is for that? Much better. And so, yeah, when we do the partial fraction, and sometimes we do end up with values like these. And so that's expected for you guys to do. You might also see within your problems like a cubic function at the bottom and 3 distinct factors, but we do not, the AP test does not have any of that on there. So this is the extent of what the AP test would cover for it. So very good. I see that a lot of you guys pulled the 1/4 out. You understood that after that, it's integrating 1 over 3x plus 2. So that would get you guys ln of, and we're understanding that we can only do ln and undo that when the bottom factor is linear. And then in our minds, we're checking our work. The derivative of ln is 1 over 3x plus 2 times the derivative of what's inside, which is 3. But since I'm finding an antiderivative, I want to undo that and multiply by the 1/3 as well. So then you have that 1/3, that 1/4 that was already pulled out. So that is going to result in 1/12. And double check our work, but we should, when we take the derivative, end up with the integrand as our answer. So very good. So just understanding that that's the possibility for when you guys do some of your problems tonight. Okay, so we have a good chunk of time